Okay, where does time begin? The international dateline? If some of you don't know what the international dateline is, there are a couple of key lines on the map of Earth, ball or flat. Well, I don't even know what the flat say, but I mean, just is suffice to say I'm open-minded. I'm still looking into that flat versus round one way or the other, but for convenience I'm going to kind of talk about everything in terms of, I guess, the globe map for now, but that doesn't necessarily mean I'm globe or flat. Anyway, on the maps there are, as you go around, there are two main lines. There is the prime meridian and there is the international dateline. And the prime meridian, you know, I'm not even exactly sure what the prime meridian is for. Honestly, I'm gonna have to look into that more. But it's in I think Greenwich or Greenwich or something, England, and it's either has something to do with where the time zones begin, or they just had to pick a spot that kind of splits the Earth in half or something. I'm not sure. It's almost like the equator, except going along from north to south, sort of. But the other important line you need to be aware of that is important to this video is the international dateline, and that is the one that sits out in the Pacific Ocean. And I mentioned in my previous video I wanted to do an experiment trying to answer the question of where time begins as it relates to both the day cycle and the year cycle. And both of these things, both the start of the day and the year cycle, are dominated by the international dateline, this fictitious imaginary line that men decided to plop out in the middle of the Pacific Ocean. And may not seem like such a big deal to us who are so far away from the international dateline. Like, I live in America and it's just, I'm so far away from it, it doesn't make such a big deal. But when you're close to that line, it does make a big deal, because you've got theoretical days ending and beginning right around that line. So depending on which side of the line you're on, you could be kind of one day behind or one day ahead. And that I've seen discussions on the internet. If you live in those areas and you're a Sabbath keeper, that can be a real challenge for the Seventh-day Sabbath keepers, because it's just like, it's a convention, it's something man made up, but it's, these islands in the Pacific, or even Australia is pretty close to there, like, and Japan, the land of the rising sun, but it's, you could live, the international dateline is not straight either. It's curvy, so like it's really messed up. But if you live on either side of that thing, you could be theoretically, if you're letting your time be dictated by that, you could be celebrating your Sabbath one day ahead or one day behind. And so anyway, and also it can also potentially mess with the start of the year. But so anyway, I wanted to do an experiment to see if I could verify when time actually is supposed to begin according to the movements of the heavenly luminaries. And specifically, I'm focusing on the sun right now, because the sun is what gives us our day cycle, and like night and day happen because of the sun, and not because of the moon, and not because of the stars, but because of the sun. And the year cycle happens because of the sun, depending on how close, like over the course of the year, the sun obviously over the course of a day, the sun obviously moves from east to west, but over the course of a year, the sun moves slightly north to south and south to north, depending on what time of year it is. And on the coldest day of the year, the sun is in the farthest south position if you're living in the northern hemisphere, and on the warmest day of the year in the northern hemisphere, the sun is as far north as it can get directly overhead. And so that was my experiment. I wanted to perform a two-phase experiment to see if I could pinpoint where the sun reaches its most extreme position on the solstice days. Because if I could figure out exactly what position, what geographic location on Earth the sun hit that position, then that could answer the question of where time begins according to the Creator and his timepieces. And so I just want to mention the book of Enoch. You know, when I read Enoch, Enoch seems to say, you know, in his day, if Enoch is an accurate source and the translation is correct, and potentially if things haven't changed since then, in Enoch's day, it looked like he was saying there were 30-day months, and then every third month, that third month would have an extra day, the seasonal day. But the thing was, it was a day. Like, it was an entire day dedicated to the seasonal transition, and that's what the equinoxes and the solstices are. So my understanding of the equinoxes and the solstices, according to Enoch, I've been leaning towards, it seems Enoch describes these events as being a day-long event. So there are some people who say that the solstice events and the equinox events are a one-moment event, like there's this magical, mystical moment that the equinox occurs or the solstice occurs. And but I just not sure I get that. When I read Enoch, it seems to be saying that these events are actually a full day event. Like, there's an entire day dedicated to the seasonal event. And it's interesting when you think about the way the portals are stacked up. And I mean, if there are 30-day months, and then some of them have an extra day, does that mean that the portals that have the extra day are slightly wider than the portals that don't have the extra day? Or I have to reread Enoch to see, but does the sun just do an extra circuit? Like, not an extra circuit, but it traces the same circuit on those days. When it gets to the solstice event, to that extreme point, does it hit the point at one moment of time and then start to return? Or does it hit the point and do a full revolution at that extreme point and then start to return after the day cycle has occurred? And so, anyway, I wanted to try and look into this and figure it out experimentally in a two-phase experiment. My first phase was going to be to look at Stellarium and see what Stellarium is programmed for, which might be just completely wrong. It's programmed software, but I just wanted to have an idea what Stellarium's saying. The phase 2 of the experiment will try to be to network with different truth seekers around the world to see if we can answer this question experimentally. So I'm going to include screen captures of all the iterations I went through in Stellarium, and I'm going to briefly describe what that looked like. But I wasn't even sure. I wasn't even sure exactly. I was, as I mentioned in my previous video, I've had trouble running Stellarium. I have 4 different computers, and it wouldn't run on 3, and finally I was able to get it to run on the 4th, and so, but it wasn't convenient to use that computer, so I've had limited time, and it's just taken a really long time to do this. But anyway, so to really quickly walk you through what I did. I wasn't an expert in Stellarium, so I kind of had to learn as I was going. And at first, I noticed Stellarium, if you hover on the left side of the screen when you have Stellarium open, a couple windows will pop up, and you can, I think they're the top two icons in that toolbar. One is to allow you to kind of adjust the time of day, the date, and actually to adjust the time of day, if you hover over the bottom, another toolbar will come up with a clock on it, and that's where you can kind of run through the hours of the day. But this other one will pop up, and you can adjust the days, the months, and the year. The other thing on the side toolbar that'll pop up is on the top is a location map, and you can kind of pick the location of where you want to view. And I'm just gonna talk about as much as I can remember here. I don't have it in front of me, but what you want to do is you want to click on that map and pick your location. You can either pick a city, or I discovered you can actually just click on the map, and the map will show you what locations are nearby once you click, and then you can go and kind of pick the exact location from a list that appears on the side. Or you can enter the latitude and longitudinal coordinates of exactly where you want to look at, and that does become important later. So then once you figure out how you're able to pick your location, then you can close that window. And what I was doing was I was looking at the past winter solstice for 2018, for starters, to try and see where that occurred. And I'm gonna have the summary of all that data in a nice Excel window. I'm just talking about it in my car. This is all from memory. I can't see it, so I'm gonna make the pictures match what I'm saying. But anyway, the data that I was looking for, I started with the 2018 winter solstice, shortest day of the year. So I was looking in Stellarium to see if I could, because Stellarium gives very precise coordinates. It's programmed, but it gives very precise coordinates. So this is just phase 1 of a 2-phase experiment. Phase 1, do it with Stellarium. Phase 2, do it in the real world. But so Stellarium gives these coordinates, locations of the sun, to a very fine decimal point. So it's very similar to what I've been doing with the shadow data. Like with the shadow data, I've been looking for the sun to reach an extreme position. But with Stellarium, I can see that extreme position because they actually give you coordinates. So I can actually look at the coordinates to a very fine decimal point, down to the minutes and the seconds, like kind of I mentioned in another video, minutes and seconds. Now I see why it's important. It's funny how that works out. But anyway, and I'm looking in Stellarium for the moment the sun is going to hit the most extreme coordinate. And again, I wasn't sure if Stellarium was programmed for this to happen at a moment of time, or if it hits that extreme and stays there for a day. I mean, and keep in mind, that's just how Stellarium, if it does, that's how Stellarium's programmed. That doesn't necessarily mean that's how it happens in reality. But I can look at the coordinate data in Stellarium, and then phase 2 will be to, we can't look at coordinate data when we're looking at shadows, but we can, if we get a tall enough sundial, we can see the movement, and we can do a couple measurements. There are a couple measurements I think we can do, both to measure the angle of the sun in the sky, but also just generally which way the shadow progresses. So, and I'll talk about that in another, I guess, phase 2 of this experiment. But anyway, so phase 1 was Stellarium, and to see if I could find the exact coordinate where the sun hits its most extreme position. Like, do you think it's going to hit that extreme position on the international date line, or do you think it's going to hit it somewhere else? And I had no idea, and I just dived in, And so more tips about Stellarium. When you're looking at Stellarium, if you click on the objects, the sun or the moon or the star, whatever you're looking at, whatever you want to look at the position of, if you click on that object, then a toolbar data will pop up on the upper left-hand corner of the screen, giving you all kinds of coordinate data for that luminary or whatever. And if you want to get rid of that, I discovered I think you can just right-click and it'll go away, and you can click a different something else. But anyway, so you need to click that, have that clicked on for the sun. Click on the sun and you'll have the coordinate data picked up. And when I started this, I wasn't sure where to start or what I was even looking for, and I noticed that Stellarium has 2 sets of coordinate systems. One I think is like an azimuth coordinate system, and one is an equatorial coordinate system. One has lines that are like a smiley face, and one have lines that are a frowny face. And by the way, I was doing most of this data was collected in the northern hemisphere, looking south. So that's the orientation of the lines for that. But I think I'm going to have to make a short and a long version of this video. I'm saying that now, so I'm probably going to re-record a short version. We'll publish that first, and then launch the second one for people who want more information, because it's just taking too long to explain. But so anyway, what was I saying? So when you're in Stellarium, I was in the north looking south, and I started with the azimuth grid system, and I went around just plugging in random different locations like Jerusalem and Japan and America, and just to kind of look to see when the sun would hit its extreme position. And at first it was a very iterative process. Like, I had to pick a location, then I had to adjust the time of day to be able to get to solar noon, when the sun would reach its extreme position in that location, and I eventually I realized, like, that after spending a lot of time on it, that wasn't going to work, because that first grid line system was just measuring, I think it was just measuring with respect to the horizon, and as you kind of go north or south on the Earth, your horizon angle changes, so that angle just wasn't consistent, and I don't know, so that was phase 1, didn't work. So then I realized I need to be using the equatorial grid system, and so then I started doing that, and I started plugging in different locations, and at first I wasn't sure what I was looking for either, and I think I ended up, I wasn't sure what I was looking for, and for some reason I got fixated on the thought that I had to try and find the location where the day like flopped from the 21st to the 22nd of December, and like when was that moment when the date changed or something. And I think that I ended up in like Constanta, Romania or something, and I was talking to this doctor, some kind of doctor of a observatory out in California, and he was like, there's nothing to what you're saying, it doesn't make any sense, and I had to rethink what I was doing there, and I realized that location only jumped out at me because that location was only, something significant was only happening there because of where the international date line was located, and that's why the day was switching from the 21st to the 22nd. So then I had to push all that aside, and I realized I need to just be looking for the extreme coordinate on the the equatorial grid line system. So I took I eventually started to zero in on this, and I think this is what I needed to do. And I noticed there were two sets. There are actually a whole ton of different coordinates listed when you click on like a luminary, and Stellarium puts that data up on the left. There's a whole bunch of data there, and I was only able to kind of figure out the equatorial data was what I was looking for, because I clicked on the icon down in the bottom. When you hover over the bottom, the toolbar that pops up, you'll see the two different grid systems. So when you click on one or the other, you'll see the grids pop up. And then I was able to kind of, when you have the date adjuster open, and you have to open that on the sidebar when you toggle over that, I think a second from the top, you can see which grid line. You can figure out which grid line you need if you adjust the months. Like pick a time of day where you can kind of see the sun in front of you, and like I said, I was in the north looking south, so my cardinal point was pretty much due south, and you'll see the sun in the sky, and you just start adjusting the month, and you can see kind of which direction the sun is heading, north or south, over the month increment. It'll make quite a significant jump as it's moving through those portals, and so you can figure out which grid line it's following, and then when you look at that data on the left, you can kind of see, okay, I see which way it's heading. It's negative 10 heading to negative 20 or whatever, and so I was able to figure out which set of coordinates I needed. But if anyone is more familiar with this and can kind of get the idea of what I'm trying to do and understands what all that data is, and if there's a more exact data that I could be looking at, please let me know. But anyway, so that's what I zeroed in on, and that is what I started to use to zero in on the question, when does time begin? And so I was watching. What I would do is I'd pick a location, and then I'd flip between the days first, so between the 21st and the 22nd, to see which one of the days had the most extreme coordinate. So I'd actually have to do 3 days of data to make sure. And so I'd flip 3 times and see, okay, which one has the most extreme coordinate. Then I would go to the clock, and I'd adjust the clock to make it run to the time of day when you'd get the most extreme coordinate. Oh boy. And now I remember it was quite an iterative process, because once I adjusted the clock, then sometimes you just want to double check the day one more time. I think it made more of a difference for the azimuth equator, or the way I was doing it initially. Like, I remember when and I'll show a picture, but when I was looking at Jerusalem, I was like, it was an iterative process, because I'd adjust the date, and then I'd adjust the time of day, and then I'd have to adjust the date again, and adjust the time of day again, and it made me think that they chose to start the clock over Jerusalem, which I think is the other kind of popular theory floating around out there. It's either the international date line or it's somewhere over Jerusalem. Those are just the two theories of men, but the question is, where does the creator's timepieces say that time begins? So anyway, I had that going on, but I think it kind of toned down for whatever reason when I was looking at the equatorial stuff. But you do want to double check, just double check the date and then double check the time of day to make sure you're looking at the most extreme coordinate. So then once you've got that one point figured out, then just pick another location on Earth and I would recommend go like 25% of the map away from that point, either around the world or across the map, depending on if you're flat Earth or round Earth, and go around somewhere and do the same thing and see what point you get then. And so then got to work here. Got to park my car, go in reverse. So then what you gotta do is then you gotta, okay, sorry about that. So then you've got to do the same thing you just did, and you're looking again for the extreme point and the coordinate, and make sure you adjust the date and the time of day to make sure you double check you're looking at the most extreme coordinate. And then once you've got that pinpointed, compare it to the coordinate you got previously for your previous location. And it's really then do it one more time, pick another location, and it's really the third point you pick that you'll start to be able to zero in on where the extreme moment, if it is an extreme moment, where that extreme moment happens. And so at this point, I think I realized that the extreme coordinate I was getting for my two different locations were slightly different. So at that point, I was able to start kind of getting a feel for what Stellarium's programming was, and it looked like Stellarium was programmed so the equinoxes and solstice events happen in a moment of time as opposed to a day of time. And so and remember, that's just programming. That might not necessarily be what is happening in reality. But I'm open either way, and I'm hoping to, whatever we see in Stellarium, I'm going to try and prove out in real life as well. That's phase 2 of this experiment. So anyway, by the second point that I figured out, it was looking like the extreme coordinate was different. So it was looking like Stellarium is programmed so the solstice event and equinox events are a moment as opposed to a day. So, but by the time you do your third point, then you're able to start seeing which direction you need to go to get to the most extreme point. And then, because the third point will tell you, okay, it's which way is it progressing. And so then you just need to kind of go back and forth, and you can fine-tune it and adjust your location. And now I'm going to mention one more tip that I noticed at this point. When you go to your locations and you click on the map, like I picked Anchorage, Alaska, because I was really thinking, for a time I was thinking, well, would it be the international date line? And then I was thinking it might be Jerusalem, and then I was thinking it might be then I was looking at the map that Stellarium has, and I was like, oh, well, that map probably tells us what the programming of Stellarium is. It's not quite the international date line, because the international date line's squiggly, but the map that Stellarium is showing me is, a straight line, so I was thinking that might be it. But anyway, the tip is, I think you're going to want to have a consistent latitude. And what I ended up picking the latitude of Alaska, but you could pick any latitude, just pick whatever location you want. But when you adjust your longitude, when you start to kind of pick points around the Earth, you're going to want to pick different longitudes, but you're going to want to pick a consistent latitude. So when you pick your city or your location, your first point, when you pick your next point, you're not going to want to enter a city. You're going to want to go to the latitude coordinates, and you're just going to want to adjust your latitude and longitude. And you're going to want to keep your latitude the same and just adjust your longitude. So you can just kind of highlight the text in the longitude box and put a new longitude in there. And I was only adjusting it by increments of 1. I wasn't going to the minutes, and I wasn't going to the seconds. I was just adjusting that grid location by 1 degree, and that seemed to be close enough to kind of give me a ballpark of what Stellarium was programmed for anyway. So and that's how you do that. And you just toggle different longitudes until you zero in on the most extreme coordinate. And when I did that the first time for the year 2018, I think it happened on December 21st. and it happened kind of on a longitude that was generally over the tail of Japan, the bottom tail of Japan. And so I was like, I'm not really sure what's going on there. It's not quite where the international dateline is, and it's not quite it's not quite at the edge of the map that's shown on Stellarium, and so I wasn't sure what's going on. But I started to. So then, once you figure that out for the year 2018, the next thing to do is to look at the next year and to see what is happening the next year. And so you kind of have to repeat the entire process that I just said until you zero in on the next extreme point, on the next year. And what I discovered is it was like, would you think that this solstice event, or the equinox event or solstice event, this solar event, would happen at the same spot every year if it was a moment? Go ahead and answer that question. The answer is, according to Stellarium, no. So, and I don't know, I don't know if that. I suppose that makes sense with the models we're given, and with the data that's being claimed, the 365-day, 0.25-day year or whatever. But anyway, that might not necessarily be reality. It could be. But this is phase 1. We're looking at what Stellarium's saying. Phase 2 will be looking at what actually happens with the luminaries, coordinating with different truth seekers around the world to try and observe this via confirmation. I'll describe how we're going to do that in phase 2 of this experiment. But anyway, when you do the next year, 2019, and you kind of go through the whole process, the location I found with the most extreme coordinate was not the same longitude, like the tail of Japan, and I'm just telling you tail of Japan as just a general reference point. It could have been any latitude. I was looking at Alaska, but I'm just saying tail of Japan because I think that's probably a geographical location that people are familiar with. But anyway, so the next location in 2019 was, I think it was over Egypt. That's when Stellarium said that the 2019 solstice event occurred. And so I could tell from that it looked like the solar event jumped approximately a quarter of the map. And so I figured, okay, that makes sense for the 365.24 days. Like, it's hard to explain, but like it basically, it's, if it is 365.25, for some reason I was that extra 1.25 days or whatever. Like or maybe it's the quarter day, or maybe it's just the quarter maybe it's that quarter that's doing it. But it's because of that extra 0.25 or 0.24 that you see that shift occur. Because obviously, an entire day cycle, you should see the sun go all the way around and return start at point A and return to point A. But for the year, it's going to start at point A and return to point B, because the year is 365.25, at least according to what modern science says, and at least according to the programming of Stellarium. So that is why it jumped. And so I figured, okay, that means the next year it's going to jump again, about a quarter of the globe or Earth or whatever. And so I did it again, and lo and behold, it did shift again. And the location for the next one in 2020 was over Nova Scotia, kind of above Maine in the United States, Nova Scotia. Any of you familiar with Anne Shirley, Prince Edward Island type area? But anyway, there was something interesting also that happened. It was either in 2019 or it was 2020, but the date, I think, switched. Like, so Stellarium was saying it happened on the 21st, and then it happened on the 22nd. That extreme coordinate was hit. So I'll have a picture showing kind of the summary of all that. And maybe I don't have time to process it now, but maybe you can process it or kind of figure out what the pattern was from there, or why that happened. But I did it one more time just so that I could kind of, or actually maybe I did it 2 more times. I can't remember if I did it 1 or 2 more times. I either did it 1 or 2 more times. I'll put the summary of the data down for you. But in any situation, either 1 or 2 more times when I did it, because I wanted to kind of see the whole, like, quote-unquote leap year cycle. But when I did it 1 more time, when I did it 1 more time to get all the way around, I did not end up over the tail of Japan again. Like when I did 1 full cycle of the leap year or whatever, it didn't even end up on over the longitude of the tail of Japan like I did in 2018. Like, so what that tells me is, according to Stellarium, the moment at which the solstice, it is programmed to be a moment. That might not be what reality is, but Stellarium is programmed so it's a moment, and that moment shifts every single year, and it doesn't even line up every 4 years. It's literally seems like it's going to be different every year, and maybe in a very long time it will actually match up. Someone might have to crunch some numbers on that to see what's going on there. Yeah, again, if this is even reality, which it might be, but try and figure out what's going on there. And because maybe it won't line up, it doesn't seem to line up every year, but maybe every like 600 years it will. I don't know. I have to crunch that number. But so yeah, that's the summary of phase 1 of this experiment. It does appear that Stellarium is programmed so that a moment, the solstice events happen in a moment. So the one thing I want to say in addition to that is like so if that's the way the luminaries work, and if we're able to, by physical observation, kind of confirm this, then the way the Creator's timepieces work, according to this data, if that's how it happens in reality, like Enoch seems to say, again, that these are day-long events. So then, regardless of if it reaches that extreme coordinate for a day or a moment, it's still gonna be the day of the event. If you're trying to go according to Enoch, and so the question is, when does that day begin? At first I was thinking, well, the day just it should begin when when we see the sun hit that extreme mark, and like I said, over the tail of Japan, 1 year, Egypt 1 year, Prince Edward Island the next year, varies every year, and so at first that's what I was thinking, and I guess according to the data it does seem to vary every year, but what I realized was, regardless of that, it is the moment for each location that sees the extreme, would see that extreme moment. So, okay, the extreme moment happened over the tail of Japan, say. So then stop the 24-hour clock right there. That is kind of the middle point of the longest day cycle is right there. So I was thinking, well, I don't know. I might have to think about this more. But I was thinking if you go east to west of that point until you meet again, like when you just keep going east and west until they actually meet again on the other side, it would be that opposite side the opposite side is where you would see the extreme point everywhere else on Earth. I don't know if that necessarily means, according to this data, that's when time would begin, but that is, for everyone else on Earth, that is when they would see the most extreme coordinate. So I would say maybe, I have to think about this more, but maybe the solstice event everywhere around the Earth would surely have to include the day that has the longest coordinate. So it's easy, longest coordinate happens at this time of day in Japan, base of Japan, like I was saying. But when does the extreme moment happen for everyone else? I think the day of the event needs to kind of include that moment, if that's how it works. So that's just food for thought. That is the long version of this. I will have a short version, and then I'll probably follow it up once I have time to process all this information. But I wanted to get that out as food for thought, and if anyone has any thoughts on that, let me know, and we'll all keep thinking about this. And I look forward to getting more and more truth seekers involved and around the world, and we can figure the times out by observation, not by this program software. Because it is just program software. It might not reflect reality, and it might not be as complicated as this software makes it out to be. Like this may seem really complicated, what I just spent time talking about Stellarium, but if you blow all that aside and go back to thinking about the shadows, I think it's just as simple as watching the shadow and seeing when the shadow hits its extreme position. And generally when it's going to happen. There's maybe a week or 2 week window where you can be diligent to get out there and make an effort to confirm this, and you just kind of record where the mark is one day to the next, and you'll see when it hits its most extreme position. And it may be that everyone on the Earth does see that extreme position. Like maybe it is like Enoch seems to say, where the sun kind of pauses on that station in the portal and does an extra circuit on that same loop or that same station. So maybe everyone on Earth, it is the same moment, or it's the same day for everyone on Earth. That might simplify it. I don't know. I have to keep thinking about it. But as far as it concerns us, I would say solstice events in real life, I think definitely the day of the solstice is just the day that you see. There's no doubt the day of the solstice is the day you see the shadow hit its extreme coordinate, whether that matches what Stellarium is saying or something else is happening in real life. I've just presented the data to ponder. And the equinox events, those are a little trickier, but if the creation is as masterfully created as it might be that you see the straight line pattern no matter where you are on Earth. You will see that straight line pattern, and I'm still in the process of proving that out. I have, if you check out my spring equinox video 2018, I discussed the geometry, not the prep for spring equinox, but the actual spring equinox. You'll see a picture of I talk about the different models, flat Earth and round Earth, and I try and piece this together, and I try and show you the geometry of what's happening to try and get that straight line pattern. And all I can say at this point is I'm not sure yet. I'm like to prove the year cycle with the solstice events, and then when I know the year cycle with the solstice events, I should be able to confirm the equinox event, and we can prove once and for all that the straight line pattern does happen on the day directly between the two solstice events. But yeah, it's just interesting if it is a straight line pattern on the equinox for everyone, no matter where you are. That is just amazing. Like you really need to stop and ponder what kind of geometry needs to be set in place for that to occur for everyone. It's really got to be quite quite amazing. But anyway, that is the end of this video. And like I said, I guess I'm going to launch this one later, and I'm going to launch just a shorter one first. And if you're interested in that shorter one, then you'll get to enjoy this whole longer one. So I guess that's it for now. Shalom, and may Yah bless as you continually seek out His truth in love with a pure heart.